What's up, team? Today we're talking about inequalities. So our learning target right above me here. I can understand what is meant by a solution of an inequality, and I can graph solutions of an inequality on a number line. We're going to do both of those in today's video. Remember, just like equations, the solution of an inequality is the set of numbers that makes the inequality true. With equations, we had a single number that made the equation true. Here, we have a whole set of numbers. Really, generally, it's infinitely many numbers that are true. There's kind of a cutoff line with inequalities. So if I said like x is greater than 5, well, 5 would be the cutoff line, and everything bigger than 5 fits into our solution set. So all of those answers would be okay. They would satisfy the inequality and make it true. Reminder right above me, I have the symbols, the less than, greater than, less than or equal to, and greater than or equal to symbols. All right, let's dive in. Okay, here's the number line. It goes on forever in both directions. Really, it's just a visual representation of all the numbers in existence. Here's 0, here's all the positive numbers. It gets bigger as you go to the right. It gets smaller as you go to the left. They both go on forever. Mine goes from -3 to 3 because that's just where mine stopped. Of course, it goes for infinitely long. Okay, say we were given the inequality. X is less than 2. And we were asked to graph this to show what it is visually on a number line. Well, here's 2, and we know that x is less than 2, or x is smaller than 2. That means all the numbers that are to the left of 2 on this number line satisfy the inequality. They all work. But also notice that x must be less than 2. It cannot be exactly 2. So when it can't be exactly 2, what we do is we circle the number, we put an open dot at the number we're talking about, and then we kind of somehow highlight in the direction of where all the solutions are. Some people do a squiggly line. Some people actually use a physical highlighter. Whatever works. Just somehow make it demonstrate that we're talking about not the number 2, but we're talking about everything to the left of 2, everything that's less than 2. So this is a perfectly good graph of this inequality. Okay, here's another example. This one's very similar. This one, instead of reading x as less than 2, it's x is greater than 2. That means x still cannot be exactly 2, but it must be bigger. That means it's to the right on the number line, because we know that all these numbers to the left are smaller. So in the same way, we put an open circle or an open dot around our number 2, and what we're going to do is we're just going to point to the right-hand side. This signifies that everything to the right of 2 on the number line satisfies our inequality. All of that stuff is in the set of solutions for this inequality. All right, this one's pretty similar, but it's different than both of the previous two. This one says x is less than or equal to 2. So that means it's really the same thing as the less than, but it includes one more solution, and that's the endpoint. So in this case, because it can be equal to, we put a closed dot, or we fill in our dot at 2, and then we're still going to point to the left, because we're saying all of these solutions are okay, but because of the closed dot, that signifies 2 is also an acceptable solution to this inequality. Okay, here's the last type we're going to talk about today. X is greater than or equal to 2. Well, this is very similar to the last one. We know that x is some number that's either bigger than 2 or exactly 2. So again, we're going to fill it in, and we're going to point to the right. So in summary, if it's bigger, we point to the right. If it's smaller, we point to the left. If it's allowed to be exactly the number, in this case it's 2, we fill in the circle. If it can't be, say it's either less than or greater than, we leave it as an open circle. All right, sometimes we're going to have to use our noggins a little bit. We're going to have to use a little bit of logic when figuring out these inequalities. So, for example, we're given the statement, x is no greater than 100. Well, that's not less than, that's not greater than, that's not one of the ones we just talked about. We're going to have to figure this out and see which one it fits into. It does fit one of these descriptions that we've just talked about, but we need to figure out which one so we know which symbol to use, and then we know how to graph it. So we're going to ask ourselves 3 simple questions. Well, the number 100 is here, so we're going to work with the number 100. You'll see that in each of my questions here. The first one is, can x equal 100? Well, if x is no greater than 100, can x equal 100? I think so. It doesn't say it can't equal 100, so I would say yes, it can equal 100. But there's more. We're not done yet. Can x be greater than 100? Well, our statement is x is no greater than 100. Well, that seems pretty clear. It's not greater than 100 because it says no. So no, it's not greater than 100. Can x be less than 100? Well, x is no greater than 100. It doesn't say anything about less than it. We just know it's not greater than 100. Well, if it's not greater, it could be less than. It could be smaller than 100. So I would say yes to this one as well. So X can be less than 100. X can be equal to 100. Therefore, our statement here is going to be X is less than or equal to 100. And when we graph it, of course, I'm going to do this very crudely here. We have a number line, say a 0, say there's 50, and say there's 100 here. X is less than or equal to 100. Circle goes at 100. We fill it in because it can be equal to, and we point to the left because that's where all the less than numbers are. So whenever you're given in a statement like this and you have to make an inequality, ask yourself these 3 questions. Of course, you're going to replace the 100 with whatever number is in your statement. This one just happens to be 100. Can X be equal to it? Yes or no. Can it be greater than? Yes or no. And then can it be less than? Yes or no. Once you have your yeses and nos, check out your yeses and make a statement out of it. In this case, it can equal 100. That's why this line's down here, because we know it can be, and that's why it's filled in. Can it be less than? Well, yeah, that's why we have less than. That's why we pointed to the left. All right, hope this video helped. Let me know if you have any questions.